When I hit record, I'm already going to stop it because I forgot I wanted to do something. Okay, so the ball's rolling. Class has started. We're official. All right. What's the acronym that we use for trigonometry? Do you remember it? Boom shakalaka. So we'll go through this fast. This should all be review. But then tell me, let's go over to this block first. Because this was like a review thing when I was in math 2. We'd already done all this, so then, we use this little matching. So who does sine go with? C. That is an identification of what SO stands for. Sine, the O and the H means opposite over hypotenuse, and that's how you identify these. Why don't you finish it off, because it's actually not bad. I think you got it. So what's ca? What does cosine go with? Ooh, let's do color coding. If anyone's colorblind, which does happen, I'm sorry, but you can see the timing of this. F, adjacent over hypotenuse. And then what's toa? Toa. Tan is D, toa. Okay, then let's stop for a second. And then I'm going to give you almost what could be considered an illegal acronym, but I don't care, an illegal way of remembering this, or maybe inappropriate, but we're all adults here. Cosecant goes with hypotenuse over opposite. I'll draw a line to that one. This is what I always tell my students. Here it comes. Sine is so, cosecant's a ho. Do you remember that from 2 years ago? Sine is so, cosecant's a ho. All right, that's online. That's for the world to hear. So secant, who do you think that goes with then? If sine goes with cosecant, what do I mean by sine going with cosecant is they're reciprocally related. There's a flip relationship. So everyone, who does cosine go with? Take a guess. No, who does cosine go with, like as far as reciprocals? Secant. So I'm going to color that and then identify that with B. So I always said with cosine, which isn't as funny, cosine is ka, secant is ha, H-A. All right, so it's just a flip of that. And then, of course, cotangent goes with who? As far as the reciprocal relationships. Tangent. So cotangent is the flip of OA. It's AO, AO. Adjacent over opposite. So when you think about your graphing calculator, stop. Hammer time. So total, but right. I don't want to make this take too long. We're already blabbering on and on and on and on. The only point of this over here, when I was talking to my 2 years ago students, obviously sine. I'm just going to erase these answers and show who goes with what. But obviously sine shorthand is sin, right? The only point of this is be able to understand cosine is COS. I'm not going to cover all the other ones. Tangent is TAN. Maybe cosecant, we have to know, is CSC when it's written on a piece of paper. Maybe we got to remember that secant is SEC. And then cotangent is COT. Because I think I did have someone today say in second hour cotan instead of cosine because they both started with CO. Then the only thing I want to identify maybe is this, and then definitely right up here what I had before. What's cosine to the negative first, which made that look horrible when I used green? Let me move that off there and maybe go yellow. And the answer to that is also called arccosine, but that really doesn't mean a lot to you. We did 2 years ago talk about inverse cosine, the same thing as arccosine. They mean the exact same thing. But what we need to know for right now, at least to get the basics of geometry figured out, write this down. This is the key. I'm not asking you a question. I'm telling you this is the key. What do you cosine? I could have picked any trig function here. What do you cosine? An angle to get a ratio? Or do you cosine a ratio to get an angle? This is so important. I think students jack this up all the time. You cosine a angle, and then the answer is a ratio. You better write that down. And what is that ratio for this cosine? What is the ratio for cosine? I'm asking ka. What does the ratio represent? Ka. Adjacent over Hypotenuse. So this right here represents, for this particular setup, adjacent over hypotenuse. Okay, so then what do you inverse cosine? What do you inverse cosine? Well, look at the thing up there and just make a guess. You inverse cosine the ratio, and what's the resulting answer? An angle. I don't think students understand that enough, and I try to hammer that point down right off the bat before we continue. And that's kind of the point of this little matching thing, but a little, I don't know, a little weird. Okay, and then we're going to zoom in on this, and actually we're going to just cover this as the examples that we need to do and be done with it. You okay there, sir? It was a big yawn. I think I got caught in the video. Not doing that anymore. Okay, student number 17. I always do this. So what we're doing is, maybe filling this in, but baloney. We're not doing math 2 anymore. This is real stuff. Sorry. What side is this? I'm going to see what you know. What side is that in the whole SOHCAHTOA, like, lining up of stuff? What side is that compared to 35? Do you know? Oops, sorry. This is opposite. I don't think she knew what I was saying, and maybe many others didn't know what I was getting at there. According to angle 35 degrees, that is directly across 35. That is what an opposite means. Opposite, across, way away from. Okay, then what side is this by definition through basic geometry? Hypotenuse? You say that? Okay, but we're going to take it. Now, use the SOHCAHTOA acronym. What trig function must we use? Sine. Okay, now, remember what I put up there before. What do we sine? Do we sine x, 8, or 35 degrees? You sine the angle. That is the purpose of why I wrote up there what I wrote. If I said that great, I don't care. This is in English. Equals what? What over what? And what is that in terms of these letters and numbers? X over 8. Okay, and then I'll leave you alone in case someone does watch. Okay, what's the trig function? Okay, what side is this? That's adjacent. I'm just using an A now. And then what side is this? Okay, now, I don't care what you set up. What's your setup? What's the equation? I need an equal sign. Okay, tell me what's first. Cosine? Good. That's usually what I start off with. Equals 6 over 23. Okay, now, do you know what to do next? Remember the beginning of the lesson? Remember when I said this? Well, yeah, we know that. We cosine an angle to get a ratio. We inverse cosine a what? Ratio to get a what? And what are we trying to find? An angle. That's a hard time finding this here. Got it. Or another way to do this is whatever you do to one side, do the other. How do you get rid of this cosine? You actually inverse cosine a cosine to cancel it. But whatever I do to one side, you have to do to the other. Either way you look at it, this is what you have to type. And then what do you guys get? Anyone type it under calculator? 74.9. I'm going to give you some word problems that don't have a drawing. Okay? But then what you got to be able to do is like read it and then actually, make sense out of it. If I give you a word problem that has the drawing, don't skip the word problem. Maybe cover it with your hand. Read it. And then see if that's the drawing you would have come up with. Use it as an aid for being able to be successful. Because once you get the drawing, it's easy. I mean, look at this drawing. I have to find this angle measure. What side is this, everybody? Come on. Adjacent. What side is this? What am I going to use? Cosine. What do you cosine? You cosine the angle. And that equals what? The ratio. In this case, probably don't have to reduce 10 over 12 because you're going to use it to solve for this. The question mark equals inverse cosine of this 10 over 12. And then you press enter and go from there. But the point of having a word problem, don't write this down as your example. I'm kind of going over this fast. Read it. Try to get the right stuff in the information, in the picture. And then after that, it's easy. I will do one maybe that we can discuss without a picture. Try to do this one, and I'll zoom in on this. And then, we'll go from there. Maybe the posted notes, I don't know what we'll do. I'll post something, but... So do this on your own, try to make a drawing, and then we'll answer the question. So here's the drawing. Here's my truck. Maybe put a wheel on there so we know, geez, it must be a monster truck. All right, and then here's the ramp. Now, there's some assumptions in here. There's assumptions that the ground is... horizontal. Is that always true? Is the ground always flat? No. So, some of these questions are not really worded perfectly for a math stickler. All right, so we're going to actually have to say that is the case. Because if this wasn't flat ground, then this angle would not be what? 90. And that's what we have to assume. So it's kind of bad. They should say with the horizontal. I don't think they really say that from the other one. Okay, where does 12 go? Does it go up at the top here or down at the bottom here? It's actually the bottom. A lot of times they say from the foot of the truck. Does the truck have feet? From the foot of the pole? Does the pole have feet? Unless you're having a nightmare and the pole's chasing you down the streets or something. No, but the foot means the bottom. Okay, and then where does the 2.5 go? Right here. Right, and then after you get the drawing, it's ridiculous. I have to find this angle right here. Oh, what's that, by the way? It looks like a cracked egg. Does anyone know what that is, actually? It starts with a T. Who said it? Theta. Theta is what they usually call it. Sometimes they use theta, sometimes they use x. I guess I should do a better job this year to tell you why they use what in each case. We'll just use x because it's introductory. And then what trig function is this? Yoink? Yoink. What trig? Tan. So it's x equals inverse tan. Not that saying that you're wrong. Just saying I got it ready. I know I have to find an angle. Whenever I have to find an angle, I use inverse. All right, and that's the case. Let me, we got a question? And then last one, this is it. And I heard from second, actually, I thought you guys had no trig last year. And I thought that was the idea of what was going to happen in Math 3, because you had it in Math 2. That's fine. Actually, you have some more practice for the start of this book. But it's fine. It doesn't matter. Second day, we're getting review. Big mistakes made on this, though. And I'm going to, well, I guess I'll draw it because you can't really see me. But here's an angle of elevation. It comes from looking up and horizontally out. That's what this says right here. This is the angle of elevation right there. Do not forget the horizontal. All right, you need two sides to make an angle. So, of course, angle of elevation, I'm looking up. That's only one side, one line of sight. You need something else. It's the horizontal. Here's the biggest mistake. If you read the directions or definition, I guess, for angle of depression, of course, angle of depression, you feel down. Or you're looking down. All right? Well, how many sides is that right now? One. Here's the biggest kicker. Students screw this up all the time. This is right. The other line of sight is a horizontal again. Both of these angles are created with a horizontal line, not a vertical. So that's the biggest mistake. The biggest mistake, I'll show you a drawing I showed by people from 2 years ago. All right? There's Mr. Samuels on a cliff, because that's where they drove me. All right? But here it is. Here's an angle of elevation. Here's me looking up to a bird. See? And then, remember this picture? And then some people cut this picture out and put it on their Chromebooks. It's very weird. I had to see it like every day. Remember that or no? C.A. is his name? All right, yes. I had a bigger picture in another set of notes, yeah. And then here's me looking down to a boat, okay? Horizontal is the key. This is not an angle of depression. This is the biggest mistake ever made. It's not with the line of sight looking down and also looking straight down. That's bad. Don't ever do that, okay? And that's all I can say about that. All right. Then maybe make this drawing. I think this was in the... No. I pulled this off the internet. Stolen from the internet. Nice. All right? I don't know who drew this. I remember grabbing this when I made these notes. The point of this question is, hey, the dog's looking up to the bird. The dog creates an angle of elevation. Hey, the bird's checking out. What's that dog doing? Is he going to eat me or not? All right? That's the angle of depression. Notice, made by a horizontal as well. Okay, so, again, defining these two angles. The point of this is, what are these two lines? Starts with a P. These two lines starts with a P. Parallel. And then the next thing I have to ask is, what are these two angles called in relation to each other? It's a two-word designation. Two words. First word starts with an A. Not adjacent. Adjacent means next to. Alternates. Alternate. I think I heard it. Interior angles. And what do we know about alternate interior angles when the sides, that's transversal to the cutter, right? The lines are parallel, blah, blah, you know what I'm talking about. They're equal. I screwed that up. Okay? So an angle of elevation is always equal to its corresponding angle of depression. And you can actually, a lot of times when I have an angle of depression question, I use the angle of elevation. Like if it said a bird is looking down to a dog with an angle of depression of, I go to the dog and make the dog's angle of elevation. Because they're the same. Does anyone know what I just said there? Angle of depression from the bird to the dog. I say, you know what? I'm going to make that the angle of elevation from the dog to the bird. Because I feel better about angle of elevations. So that you can put in the book, feel good about it. So I guess one little last thing to bother you, make this drawing. Because once you make the drawing, it's easy. Okay, there's a drawing, and we said, it was a little bit, we had some troubles where 500 goes. Probably could be worded a little bit more specific, but they're 500 meters directly away is what that meant. So there that is. Finding x, and then we talked about that's opposite, that's hypotenuse, so it's sine. And then you multiply both sides by 500. Okay? Worksheets due when, everybody?